Now that we have quickly cleaned our data and gotten it ready, this video is going to show you how to create graphs using the GGPlot 2 library. In this GGPlot, GG stands for Grammar of Graphics, which is a set of principles informing the representation of data. Every GGPlot is going to contain a core set of elements: the data we want to plot, which elements of the data we want to visualize, the kind of graph we want to use, and any additional information or modifications that we want to make to our graph. GGPlot may look intimidating at first, but keep in mind that there are three basic components each visualization will need to have. One, you will need to have a data equals statement. You will also need to have an AES function, which is the aesthetic and describes the specific variables you want depicted, and a GEOM underscore function, which tells what kind of graph you want to use to display your data. In this video, we are going to be using the Frankenstein count data from the previous video in order to create a GGPlot. Before we begin, it is important to note the GGPlot has its own version of this pipe operator. Its version of the pipe operator is the plus sign, and it is going to join various GGPlot functions into a single statement. Let's get started with an example. First, we want to use the GGPlot function, and we are going to say our data is equal to our Frankenstein underscore count variable from the previous video, and we want to only look at the top 10 words in that counted list. So we're going to use our indexing tool to say we want to look at 1 through 10. Then after this parenthesis, we are going to use the plus sign as our pipe operator, which is only what you do in the GGPlot. Then we are going to use our aesthetic function to say we want our x variable, or what is going to be on the x-axis, to be equal to the word, and our y-axis we want to say is the number of times the word occurs. Then using our GGPlot pipe operator, we are going to say we want to make a point graph. So we are going to say geometric underscore, and you can see from this list that there are tons of different graphs. There are area graphs, bar graphs, box plots, contour graphs, all of these different ones. But we want to use a point graph for this first example. Let's quickly run this line of code to see what happens. Once this code has finished running, you will see that a plot appears over here under your Plots tab. Let's make it bigger to look at what's going on. You will see that the words have now been listed across the bottom on the x-axis like we requested, and N has been listed along the y-axis. Then each point is the number of times each word appears. Using this graph, we can see that he occurs most frequently, she occurring second most frequently, and the rest of these words scattered amongst them. Now we can have a discussion about whether or not a scatter plot is the best way to portray this data. In order to get a good comparison, let's try creating a different type of plot. For this, we're going to use the column function, which will give us a bar graph. Again, we are going to start with our GGPlot function. We are going to tell it which data to take, which is going to be our Frankenstein count data. We are going to again index for the first 10 words. We are going to add our little GGPlot pipe operator. Our aesthetic is going to be the same, with words coming first, and then N. And you can see here that I just have word and then N instead of x equals word, y equals N. And this will do the same thing because x will come first and then y. Add another GGPlot pipe operator, and instead of GEOM point, we will type GEOM underscore COL, which is a column or a bar graph. Let's run this graph to see what happens now. Zooming in on our graph, we will see instead of points, we now have bars. For this first example, The bar chart is definitely much easier to read and easier to visualize which words occur most frequently. However, if you have too many words along this x-axis, your words are going to run into each other and make your axis hard to read. If you want to reorient your graph so that your words are along the y-axis, we can use the flip function to do so. Let's see how this is done. First, we are going to add another line of code to our GGPlot function, and we're going to call the coordinate flip function here. And when we do so, you can now see that our x values have become our y values and vice versa. Now, they will not run together and get mixed up in each other, and you will be able to easily read them. The next thing we can do with GGPlot graphs is create custom labels. To do this, we are going to use the x and y label functions. If you don't want any label along a certain axis, you can type no without quotation marks in the function, and that axis will not have a label. To do this, I am going to continue adding functions with our pipe operator. So, under our column graph designation, we are going to use the x label function to say we want words, add our plus sign, and then use the y label function to say we want number of occurrences. Then our coordinate flip, and now we can run this code and look at our new graph. Zooming in, we can see that our axes have now been labeled as words and numbers of occurrences. You can also add a title by using the GGTitle function, our quotation marks, and saying we want to call this Frankenstein primary words. Now our final graph looks like this. It has a title, axis labels, and is very easy to read. Finally, we can start manipulating data within our GGPlot package. For this example, let's say we want to plot words that occur in Frankenstein 75 times or more. We can specify this data at the start of our code and then follow the same GGPlot pattern. So we are going to take our Frankenstein count variable, use the pipe operator, filter for n greater than or equal to 75 occurrences. Again, take our pipe operator. We are going to mutate this, and then we are going to reorder to make our graph look nicer in the long run. Add another pipe operator, and now our GGPlot. Now, keep in mind that once you start the GGPlot function, your pipe operator is going to change from the percent sign to the plus sign. Let's make our GGPlot, add our plus sign, tell our aesthetic, which is going to be our word, and then our number of occurrences, another plus sign, state which kind of graph we want to make, which was going to be a column or bar graph, give our labels, which in this case we will have no X label, but we will have a Y label, and now we're going to flip our coordinates again to make our data look more presentable and easier to read. And then we are going to add a title. To explain a few of the first lines of code, we are taking our counted number of words, filtering for words greater than or equal to 75 occurrences, and then this third line of code here is using the mutate and reorder functions to make our data a little easier to handle. The mutate function is telling RStudio to add a new variable to our dataset called word, and then the reorder function is telling RStudio to reorder the graph from the greatest number of word occurrences to the least. This way, when we graph the data, instead of a mixed up graph like this, we are going to have a graph where the words appear in order from greatest to least. Let's see this happen in practice. Here we now see Frankenstein primary words with our greatest number of words appearing at the top, going down to our least number of words. If we remove the reorder function, let's see what happens then. Here you can see that we have the same words, but they appear in a much more scattered and less easy to read way. We can see that using the reorder function created a cleaner visual representation of our data that progresses from highest to lowest number of occurrences. Keep in mind that we are not specifying the data set we use in the GGPlot line because we have already specified that data set in the 2 lines above using the pipe operator and the filter functions. Finally, we can take a graph and assign it to an object. So we're going to make an object of our top words. Let's assign it to the Frankenstein count variable, use our pipe operator, and then add in all of our filters and graphing material. If we run this line of code, we will get something called Frankenstein top words. Now we need to call that variable in order to see our graph. Once we call this variable, you will see your graph appear in the Plot tab. Keep in mind that these are the 2 ways you can make graphs. You can either simply write the code for the graph and have it appear with your plots right away, or assign your graph to a specific variable, and then that variable will need to be called in order for your graph to appear. Now you have all the tools you need in order to create graphs to help you visually represent the data you are discovering.